That is off a test. That is off a test. That's a test I gave a year ago. That's number 4. It's number 4 off of a test I gave last spring. Now the one we just did, okay, the one that I just did was very involved. Okay, that was a lot going on in that problem. But if you want a flavor for the type of question I could ask, there's one. The worst thing you could do for yourself is spend 30 minutes doing trig sub when you can do basic U sub, right? So does this go with basic U sub? See, these are those little subtleties you've got to kind of get squared away first, because the best you could maybe try for is this, right? Wouldn't that be really nice if I could do that basic U sub? Then the derivative of this would be negative 18x dx. Do I have x dx? Well, I could peel an x off, couldn't I? So I could rewrite this as x over root 1 minus 9x squared. Then I have my x dx. So that I could somehow get in terms of u. I'd scale it and stuff. This would be root what? U. But what's x? You have to solve for x here. And you're going to introduce a radical again, aren't you? If I have to solve this for you, for x. If I solve that for x, I'm going to have radicals involved. Not good. You're going to be back where you were. Do y'all see that? So U sub's not going to work. What would have worked? What would U sub have worked on? If I tweak that, if that was just an x, it would work. But if it was a 3, it would work too. Because if that was a 3 and I peeled one off, this would be x squared now, right? And now when I solve this for x squared, it'll be linear. I don't have to take a square root. And it would work perfectly. So those are the types of things you have to pay attention to on the test. Because time will be your main enemy on the next test. In identifying the right method and knowing what to do and not wasting time doing something you shouldn't be doing.
So what are you saying the fastest method would be on that?
On this one?
Yeah.
Trig sub. Also, I'm only showing you this because I've seen this happen before. The student will take that and write that down. So like they go, this is equal to this. What did they do? They squared the top and bottom. They said, you know what, I don't like square roots, so I'm just going to square everything. You can't do that. You can square both sides of an equation. You're always allowed to do that. But you are never allowed to take an expression and just square it and expect that it's the same thing, right? Like if I sit here and I say, hey, look, everyone, look, 4, right? And then you say, okay, great, 4 squared is 16. They're not the same thing, right? When you square something, it's not the same. Now, if I write this, x equals 4, and you square both sides, we get x squared is 16. Now we're still maintaining some of the relationships between x and 4. So equations you can square both sides, expressions you may not. You cannot do that. Like I said, I'm only showing it to you because I've seen people do it, and I'm like, whoa, where'd that come from? Well, I didn't want to work with the square root. You have to. All right, so what do y'all see happening here? We only have 20 minutes, so I don't think we're going to get through this one, but let's try. So you're thinking square root of which one? A squared minus x squared? With what issue do you have, though? What's the problem? The 9. So let's take a 9 out. If you were to sit here and look at this, 1 minus 9x squared, and I were to ask you to factor 9 out, what would be left in there? 1/9 minus x squared. And now that root 9 is really a 3, isn't it? And that can go out, that can go completely out. And on the last problem, it was cubed. Remember, it was like that root cube. So before we popped the 2 out, we had to make it an 8. This time, that 3 that's going to come out, nothing happens. It just comes right out.
Okay.
So that new integral is 1/3 integral. Yeah, I'm just rewriting it right now. I'm not actually making my trig sub yet. 1/9 minus x squared dx.
Why is it 130 again?
Remember, this was on the bottom, right?
Okay.
So that 9, I split it into 2 roots. Root 9 times root 1/9 minus x squared. That was 3, and since it was on the bottom, it comes out as a 1/3. Maybe I'll make it look further down. All right. All right, I think now we can do it, right? What is the trig substitution that you make when you see this? X is a sine theta. What's a for us? 1/3, right? The square root of 1/9. X is 1/3 sine theta. Derivative comes next, 1/3 cosine theta d theta. And then you have to figure out what the root part is, right? And I'm just going to save us some time. Equals ... 1/3 cosine theta. Those are your 3 pieces that you need. Okay? Rewrite time. Have I not called on anyone? Because I'm going to give a quiz grade for this. Has anyone not been called? No? Okay, everybody, you have a free 100. Everyone's got 100 on a quiz. Isn't that great? All right. Let's rewrite. 1/3 integral. What is x squared? The numerator, x squared. 1/9 sine squared theta. Over. What is the square root of 1/9 minus x squared? Where's what?
1/9.
This, yeah, the x right here squared. This is x, and I square it, so, yeah?
It's going to be, the bottom is 1/9 minus 1/9 sine squared theta.
We already did that, though. The square root thing, I already figured, well, I figured it out, but I didn't show it all. I just wrote it down. So it's just 1/3 cosine theta underneath?
And then it's going to be a cosine theta.
Yeah, and then don't forget the dx, which is 1/3 cosine theta d theta.
Sir, I thought
Yes.
that the square root of 1 minus 9x squared, wasn't that equal to 3 times the radical? 1 minus x squared? So wouldn't you have just cosine theta on bottom?
Not quite sure I'm following you.
Okay, never mind.
Are you sure? Do you like what you see?
Yeah.
Yeah, this is nice, isn't it? You'll see what's going to happen? These cancel. The 1/9 is going to go out as a 1/27th. And you'll be left with sine squared theta d theta. And we love sine squared. See, if I use like words like that, does that make up for my bad words? We appreciate the fact that we're seeing an even power of sine.
Are you going to give us bonus points for that?
I don't know. How do we handle even powers of sine? Half angle identity. So this is going to turn into 1/2 times in parentheses 1, blah, blah, blah. Keep going. 1/27 integral 1/2 times 1 minus cosine 2 theta d theta.
And then we just take off 1/2.
Take the 1/2 out, yeah. I think that's a good idea. Any questions on what I did there?
And just, we gotta take it.
Yep. We should be at a place where we can just crank out the antiderivatives of each one of those. Antiderivative of 1 is just theta. So I'm going to do this 1/54th, and then in a bracket I've got theta minus, what is the antiderivative of cosine 2 theta? 1/2 sine 2 theta. 1/2 sine 2 theta plus c.
Now we change it back.
We got to get it back. Let's distribute that 1/54th through.
Do we do it? Do we have to distribute it first?
You don't have to. No, absolutely not. You can leave the 1/54th out there. It's really up to you. I'm tired of doing math. Have you all ever had that feeling? Not yet. Okay, minus, what is that, 108? 108. Sine squared theta, and then plus c. All right, now I know we're coming to the end here. I know a lot of you are sitting there watching me going, you know what, I think I got it. I get this. I just need to go home and do my homework. And I agree with you. But this one is a little different. And particularly because we have sine 2 theta. And, well, our triangle, remember when we draw our triangle, it's based upon a triangle that has theta as the angle. Because it's based on, for this one, it's 1/3 sine theta. Right, that's what our sub was. So this is really 3x is sine theta, multiplying both sides by 3. And that means that I should have 3x here and 1 here. Because sine is opposite over hypotenuse, so I rewrite that as a fraction. So this gives us me information about theta, but it doesn't give me information about 2 theta. And you don't just double the answer, unfortunately. So can you think of any way that I can handle that then?
There's a property to sine.
Yeah, there's a double angle identity that we're going to use. So going back to pre-cal, one of those ones that they told you is real important that you remember is that sine 2 theta is equal to 2 sine theta cosine theta. So before I do that, anything over here, I'm just going to rewrite this. 1/54th theta minus 1 over 108 times 2 sine theta cosine theta. Pre-cal got me to that. And now I can use the triangle because the triangle says, gives me all information about sine, cosine, tangent of theta. One 1/54th times, what's theta?
Inverse sine theta 3x.
Inverse sine. So you're going to go to this equation right here. You're going to take arc sine on both sides. This one right here. Arc sine on both sides. So theta is arc sine of what? 3x. And then minus the 2 and the 108. Reduce out again. 1 over 54 comes back. And sine theta. We already kind of knew what that was. It was 3x, right? What about cosine theta? I never got this side, did I?
It's 1 square root of 1 minus
1 minus 9x squared. So cosine should be this over this?
Yeah.
And we're there. That was a test problem.
When you left like that, you'd be okay, right?
Mm-hmm. Just like that. Well, that actually only took us 8 minutes.
Oh, started so.
Because you went through those all the little parts.
Yeah, kind of. So, I mean, really, how are y'all feeling? I mean, I'm just tired because it's Thursday. I've had a long week and, you know, but are y'all feeling like this is,
Not that bad.
it's okay?
Just tedious.
It is tedious. There's plenty of room for mistakes.
But the steps are pretty kind of easy to remember.
Good,
Yeah.
good,
They're simple steps.
good. So what,
It's not hard, it's just tricky.
yeah, I'm going to show you one more. 'Cause I know you want to go. I want to go worse than you do, okay? But I'm going to show you one more. And if you don't want to write this down, you don't have to. I mean, you can just sit there and watch me. But there's one particular formula that is in your formula sheet. It might be u squared plus a squared on the formula sheet. But what does that say on your formula sheet the answer is?
A tangent theta.
1 over 1 over a times arctangent of u over a, right? You see the 1 over a out front? What formula is that? 17. Formula 17 says that this should be equal to 1 over a arctangent of u over a. Now, I told you to remember this formula and not to forget it because it would come up quite a bit, and that you should all recognize that as being arctan x, right? What I want you to realize now is that what I told you to remember is just one specific instant of this formula, when a is 1, right? When a is 1, this right here, a squared, is 1 squared. Then this formula becomes 1 over 1 arctangent of u over 1. So this would just be arctan x. Does that make sense? We replace all the a's with 1s. That formula up there is more powerful. Where does that formula come from? Well, here. Here's where it comes from. We're going to look at that integral, and we're going to use trig substitution. Okay, here it is. I'm going to rewrite this as 1 over the square root of a squared plus u squared squared. Would you agree with that? When you square the square root, it essentially is gone. So what do I use as my substitution if I see square root of a squared plus u squared? What is it? A tan, right? Now I'm going to use it. I'm going to use, instead of saying x equals a tan, what am I going to write? U equals. U equals a tan theta. Please sign in on the column that doesn't have any highlighting on it. All right. Du is a secant squared theta, d theta. And then I have to find the root part, right? And if I do that, and do all, plugging in the u in here and all that, you should get a secant theta. You had, yeah, please do. Good? All right, so now rewrite this. This is going to be integral of 1 over, what's this root piece? That's a secant theta, but then I'm squaring it. So a squared secant squared theta times, now du is a secant squared theta d theta. And your secant squareds are gone. One factor of a is gone, which leaves you with a single a in the denominator, right? So I'm going to write on the outside 1 over a, because that's a constant, integral of 1 d theta. Right? Everything else is gone? What's the antiderivative of 1 with respect to theta? Just theta? So this is 1 over a times theta plus c. Yeah, now what's theta? You have to go back to this. U over a is tan theta. So take arctan on both sides. And you get theta is arctan of u over a. And that's it. 1 over a, arctan of u over a plus c. That's the formula. That's where most of those formulas on your formula sheet come from. Most of the ones that involve radicals or perfect squares that are either being added or subtracted together like this, most of them, the formula is created using trigonometric substitution. Is there a question, Laura? The what? Okay, so I would have replaced my u with a tangent theta, so a squared tangent squared theta, then factored out an a squared. You good? Okay, factor out the a squared, it comes 1 plus tangent, turn it into secant squared. So I've kind of stopped showing this step now. All right, well,
And 4 points on the next.
4 points on the next quiz grade, is that what you said? What's your homework?
To finish off the rest.
Yeah, basically finish this off. Remember, it's page 326, not, I guess you can't see that. All right, so 39 through 61 odd,
And 1 through 27 on.
and then, of course, the 1 through 27, but enjoy it. We come back, we do partial fraction decomposition. That's our last technique of integration.
I sent you a message in Canvas
Okay?
about the homework solution that